Hey guys, so today we're going to have our second lesson of our online learning. We're going to be focusing on surface area today. And I'm going to call this surface area 1 purely because we branch out a little bit in our next lesson, which I'll probably be knocking over today as well, but as a separate video. So surface area, this will probably be a little bit of a recap of things that you've done in the past, particularly in stage 5. But surface area is just essentially, if we were to find the area of each of the faces of an object, so whether it's a prism or whatever it might be, it could be a pyramid, we're just adding up all the different areas of the faces. So the reason that this is important is because it's pretty applicable to real life. So for instance, if we were to make a tent, we might need to know how much fabric is required. If we were to paint a new room, we would need to know how much paint to buy. And those are probably two pretty good examples. And eventually what we're going to be branching into is volume, which again will be a bit of a recap, but that'll be later on. So what you guys need to be able to do is you need to be able to solve problems involving surface area of solids, including but not limited to prisms, cylinders, spheres, and composite solids. So first thing we're going to do is we're just going to recap exactly what total surface area means, and then we might just do a little bit of a quick recap of what a prism actually is. So I'm going to make a little subheading, total surface area. Now, total surface area is, if we want to get technical, total surface area of a three-dimensional object is the total area of all of the outside faces or sides. So I'm just going to jot that down as a dot point. So the total surface area, and sometimes we abbreviate this with capital TSA, of a 3D object is the sum of all areas of the outside faces. Now, I know I didn't write down what I had initially said, but living fast and loose, this is what happens sometimes. Of the outside faces, and sometimes we call these the sides as well. So, for a prism, I'm going to make a little subheading now about prisms. A prism is just the fancy word that we use for a three-dimensional shape with identical opposite ends joined by straight edges. So if we go right back into primary, I can just imagine it now. Your teacher would have been talking about taking a butter knife and slicing the shape in half and having a look at whether we had the same shape in both sides. Now there is one condition though, and that condition is that we have to have a polygon at either ends. So what this means is we can have rectangular prisms, triangular prisms, pentagonal prisms. We cannot have a cylinder being classed as a prism because we do not have a polygon at either end, we have a circle. So a prism is a three-dimensional shape with identical opposite ends. Joined by straight edges. We say that it can be sliced into identical slices, which we call the cross section, which we actually talked about a cross section in yesterday's lesson with the pond. We were trying to work out the cross sectional area of the pond. So essentially what I mean by that is, let's say that we've got a rectangular prism. Now please bear with me. Ooh. Oh goodness. All right, we've got a cross section, and so what I mean is, if we were to cut it down there, down there, down there, we'd get the same shape each time if we split it apart and we had a look at both ends. And that shape, of course, would be like that. So this is an example of a rectangular prism. And it gets its name from, if I dot this in, our rectangles at either end. And just remember, rectangle, a square, I know it looks like a square is a special type of rectangle. Now we don't stop there, we can also have triangular prisms. This one's going to test me out. Ooh, so far so good. So this is a triangular prism. You guys guessed it. Gets its name from the triangle at the top and the bottom. And just as another example, I'll draw you my famous pentagonal prism that I've been working on in my spare time. Oh geez, pentagonal prism. All right, now I'll leave it like that, but just remember again, pentagons, top and bottom, but we're not limited to these prisms. Of course, we've got hexagonal prisms, octagonal prisms, and so on. I'm going to make one last note. A cylinder is not a prism, and the reason for that is, as we said, it doesn't have a polygon cross-section, or its opposite ends are not a polygon. Awesome. Now, sometimes when we're thinking about how we might find all the outside facing shapes of a prism, we need to think about the net. And so similarly to all this discussion about prisms, we're going to take it right back to primary maths. So for instance, we won't harp on about this too much, but if we, let's say we've got an object like so, rectangular prism, and we've got our height, we've got our length, and we've got our width. When we unfold this shape, so it's kind of like imagining that we've got a package that's in this shape. If we flattened it all out and stood on it and made it completely flat, it would look like this. So here we'd have our top, we'd have our front, we'd have our bottom, we'd have our back, and then we'd have our left. We'd also have our right. And so essentially, if we're trying to find the total surface area of this shape, so we'd be trying to find the area of this, and then we'd want to find the area of this, and finally we'd want to find the area of this. What we actually need to remember is that we're not just finding this area once, because we actually have the same shape on the bottom. Same with here at the front, got the same shape at the back, and then on our side we'd have the same shape here. So it's just something we ought to keep in mind. I don't expect you to draw our net shape every single time, but just something to keep in mind. So as a general rule, I might just write this out, and also if I was to define all these, we'd have height, length, width. That's how it would translate across. We would need to have 2 times the top, because we'd have this one, and our bottom, even though it's top and bottom, they're the same size. We'd have our front and our back. And then we'd also have our right and our left. And so what happens is, if we wanted to find the total surface area of this shape, which is a rectangular, rectangular prism, we would find that it is 2 lots of the length times the width plus the length times the height plus the height times the width. Now, I actually draw this out. So our h times our w, that would be our left and right here. So that's where we get that one from. Our length times our width would be our yellow. And then our length times our height would be our blue, our front and our back. And so just keep in mind that this 2 comes from the fact that there's 2 of every side, sorry. Now there isn't really a specific rule that I need you guys to follow, but you just need to be able to stop, think about it, break the shape down by yourselves, and then go from there. So I'll give you an example. And our worked example is so. Find the total surface area of the prism. The prism below. Alright. Now, let's get my art on again. We're going to have, looks like this, one of these. And we'll connect it up like that, and that angle in there is a right angle as well. All right. And we need some measurements. So we got 10 meters up here, we've got 3 meters down here, we've got 8 meters over here, and then we got 6 meters over here. Now, this question says draw the net. As I said, I'm not going to go through how to do that, but it's just as if you're imagining that you're unfolding a package that's this shape, which would be a pretty crazy package. I'm more interested in whether you can find the surface area. So what I'm going to go through and do is I'm going to go through and I'm going to label all my unique sides. So I'm going to call this one A1. And remember that if this one's A1, then this bit down here would also be A1. This part right here, that will be our A2. This face here will be my A3. And then we have to remember that this back face there is going to be A4. So let's think about what each of these shapes might look like. A1, what shape is it? We know it's a triangle. So the area of a triangle is a half times the base times the height, which is going to be a half times by 6 meters, which comes from here, times by the height is 3 meters. No, 8 meters. So for this up here, we're using this here and this here. So we've got 6/8 are 48. And a half of 48 is 24 meters squared. So there's our A1. A2, it's a rectangle. Area of a rectangle is length times width. So it's going to be 8 times 3, which is also 24 meters squared. A3, which is our back face, it's a rectangle. So again, length times width, it's going to be 6 times by 3. So 6 times by 3 for this shape right here. 6 3s are 18 meters squared. And for A4, our final shape is again going to be a rectangle, so length times width, which is 10 by 3, 30 meters squared. So 10 by 3 for our A4. Alright, now we're nearly done. I believe we've done all the hard part. So our total surface area of our triangular prism will be equal to A1 plus A2 plus A3 plus A4, and we're just going to sub in all those values. So we've got 24 meters squared, another 24 meters squared, 18 meters squared, and we've also got 30 meters squared. So we add all them up, we get 48, 58, 64, no, 66, 96 meters squared. That's interesting. They've got a different answer. So we got 24, 18, 30. Looks like this one's been doubled. Oh, of course. It is 2 lots of A1. 2 lots of A1. And we are going to get 120 meters squared. So I apologize for that. But remember, at the start, we were talking about A1 being up here. And we also had A1 down here. So that's where this 2 times A1, 2 times A1 comes from. All right. So there is our total surface area of our triangular prism. The next thing that we're going to be looking at is the total surface area of a cylinder. So what have we written before? Prism. Okay. So here we're going to go surface area of cylinder. It's a little subheading. Now, we're all experts at cylinders. We've been dealing with circles and stuff quite a bit over the last week or two. So obviously, a cylinder is going to look like so. We know that we've got the radius here, we've got the height here. So what we need to think about is when we unpack our cylinder, we're going to have a circle on the top. That's pretty self-explanatory. We're going to have a circle on the bottom. And if we think about taking this, this face of the cylinder right here, and if I'm looking at it from top down, it's going to look like a circle. So this is me looking at a top view of the cylinder. So if I were to break it here and unwind this, it would actually become a rectangle. Now this rectangle has a height of h, but it's this length along here that gets a little bit tricky. So if we think about taking our circle, and let's grab it by here, and we bring it out so it comes out this way, and we grab this end and we drag it out so it comes out this way. This is actually the circumference of our circle. This right here. The circumference of a circle, as we all know, is 2 pi r. So, in our little cylinder, the total surface area of a cylinder is going to be equal to pi r squared for our top circle, but we have to double it because we got two circles, plus, I'm going to put brackets around it, 2 pi r for the radius of our circle, which has been drawn out into a rectangle, times by h. So here is one of our rules. Now, I don't expect you to remember this rule, but you should be able to work it out in any similar questions. We can actually break this down a little bit in that we can factor out 2 pi r out of this first bit and this second bit. 2 pi r, so what would actually be left behind is r plus h. Now, in my mind, if you can remember that top bit here, that's fine, but it's actually more important for you to be able to derive it yourself. And so you just have to think about it in terms of its net, like what we had just done here, where we broke it down into a circle, a rectangle, and another circle. So finally, if I do another example for you, worked example. We're going to calculate the total surface area, TSA, of the cylinder. Correct to 2 decimal places. And our cylinder looks like this. Whoa, that's not much of a cylinder. looks like this. We've got a measurement here from end to end of 68 millimeters. We've got a diameter, so that's important, a diameter of 40 millimeters. We're going to get, let's break it down, A1, A2. A1 is the circle, and we know the area of a circle is pi r squared. It's going to be pi times by the radius, which in this case is going to be 40 over 2, or 20 millimeters squared. Got my calculator here. We chuck it in our calculator. Beep, 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 beep. Boop. And we get an answer of pi times 40 over 2 squared, 1256.64 millimeters squared. Next, we're going to have to do A2. A2, as we know, when we unfold it, we're unwrapping it, turns into a rectangle. It's going to be length times width. Now we know that our length is going to be 68 mil. However, we don't know really what our width is going to be, because if you think about it, we unwrap this, so it has looked like this, but we're going to sort of like tear it along the back, and we're going to bring this out, we're going to bring this top bit out, and we're going to end up with a rectangle that's 68 millimeters long and the circumference of our circle right here. So it's going to be 2 pi r, which is 2 times pi times r is 20. So we've got 2 times pi times 20, 125.66 millimeters. So I'm going to add that in, times 125.66. Alrighty, so we go 125.66 times by 68, and we get an answer of 8544.88 millimeters squared. Then to get our total surface area of our cylinder, it's going to be, I'm not going to make the same mistake this time, 2 times A1 plus 1 times A2. So we got our two circles. We're going to get 2 times 1256.64 plus 8544.88. So I whack that in my calculator. We get an answer of 11058.16 millimeters squared. 11058.4. So they get 0.41. In my mind, that's close enough. It would be a rounding error, just because of pi, pretty much. So 11,058.16 millimeters squared. And then we just finish off, as always, with a therefore statement. Therefore, the total surface area of the cylinder is 11058.16 millimeters squared. Alright guys, so that'll do us for our first lesson on total surface area. Keep an eye out for some practice questions.